For this video, we're looking at scientific notation. So scientific notation is a method to write very large or very small numbers in a more compact format. In this format, we write the number in terms of powers of 10. A number is written in scientific notation if it's written in the form a times 10 to the n, where the absolute value of a is between 1 and 10. So it's strictly less than 10, but it can be equal to 1, and n is an integer. So we write the digits as a decimal between the number 1 and 10, inclusive of 1 but not of 10. Count the number of places that you move the decimal point, and multiply the decimal number by 10 raised to the power of n. If you move the decimal left in a very large number, n is positive. If you move the decimal right, it's a small number, n is negative. So let's do some scientific notation here. And we have, so I'm going to put the decimal after the 2 here. So this decimal moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So this would be 2.34 times 10 to the, did I say 10 times? Yep. Okay, the next one, I need the decimal to be between the 3 and the 2. So that's moved 1, 2, 3, 4, 5, 6, 7 times. So 3.2561 times 10 to the, oh gosh, I need to remember what I say. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 times. For this one, now it's going to be moved to the right. So it's going to go 1, 2, 3, 4, 5, 6 times. So 1.352 times 10 to the negative 6. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5.543 times 10 to the negative 9, because it's less than 1, and it's negative out front because it's negative here. Okay, let's go ahead and talk about converting from scientific to standard notation. To convert from scientific notation to standard notation, move the decimal n places. To the right if n is positive, to the left if n is negative. So we have 2.3427. We're going to move it 12 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a 0 there, there. Just filling in some zeros here. So there's going to be a comma here, comma there, comma there, comma there. So 2, comma 342, comma 700, comma 000, comma 000. For the next one, it's the 5th power, so 3, and since there's no other decimals, we put 1, 2, 3, 4, 5 zeros there. It's negative, put a comma there. Here we have, I'm going to write it over here, 4.47, and it's negative 5, so it goes to the left. 1, 2, 3, 4, 5. So it's 0.0000447. The last one, it's going to be this 3.051. 1, 2, 3, 4, 5, 6, 7, 8, because that was a negative 8. And it's negative out front. So it's 0.000003051 with a negative out in front. Okay, let's talk about using scientific notation. When using scientific notation, use the rules of exponents. Keep the non-10 digits together and the tens together in multiplication. So that doesn't sound too cryptic. So the point is kind of like terms. So the 7.8 and the 1.1. So we have 7.8 times 1.1 times 10 to the 41 plus 9. So 7.8 times 1.1 is 8.58 times 10 to the 41 plus 9 is 50. Now we have division going on, so we'll do the dividing part. So we have 9.24 over 1.1 times 10 to the negative 8 minus negative 17. Excuse me, 9.24 divided by 1.1 is 8.4 times 10 to the, so double minus negative makes that plus a positive, so 10 to the 9th. And here we'll have our 3.37 over 2.1 times 10 to the 5 minus negative 4. So I get one, boy, this is a nice one. I say that sarcastically. 1.604761905 times 10 to the 9th power. Now someone is going to argue with me about significant figures, but I'm not worried about that because I'm a math person. Okay, now we have 1.005 times 6.7 times 10 to the negative 12 plus 15. So 1.005 times 6.7 is 6.7335 times 10 to the, we have negative 12 plus 15 is 3. And I want to clean that up a little bit. Times 10 to the negative 12 plus 15. Okay, much better. I think this is the last example from this section. In August 2004, the national debt was 35,123,900,000,000. The population of the United States was 336,910,575. What is the debt per person? So we take this, it might be easier to write this in scientific notation, so 3.51239 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then we have 3.36910,575. I guess I could have rounded that a little bit. Times 10 to the, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we do 3.51239 divided by 3.36910,575, and I get 1.02425. Sorry about that mistake. 1.04252887 times 10 to the 13 minus 8 is 5. So the way our government is spending, we would owe, so I'm going to move it 1, 2, 3, 4, 5, 104,252.89. So it's more than that now because it goes up every second. So $104,252.89 per person is what is currently owed because the government borrows money to give people money. Okay, hope that helps.